Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with LearnBay.co. Happy learning!
Okay, let's continue. Okay, so yeah, my question was, let's say if there is a general autocomplete, then what is text generation, or like how would you train or think about text generation really?
It will be a probability of the words which are linked, and based on what you type, it takes the best probable word which is there.
No. Training. You are just explaining me the phenomenon that what is happening. How would you train that? Okay, for training, let's say if I say text generation is a supervised training system, then what is the why exactly? What is the input and what is the why?
It will learn. The input will be depends upon the case. Like input would be all the feed which has happened for whatever domain I'm looking for.
No.
Like no.
Yeah, that's the issue. Okay, no worries. I will explain you. There is no problem. Okay, so basically, what Google and these guys do is, let's say you know about Google News, right?
Yeah.
So basically, Google owns this definitely, and basically all the news that has ever been generated here, and I think this is active from long time to be very honest. Google has complete control here, right?
Yeah.
Okay, great. So let's say I want to understand why floods occur in Hyderabad. Okay. Now it is going to be slightly tricky, but I will try to explain you what will happen. Okay. So you know what is the training data exactly and how it works. Okay. Let's say you have to select a window. Okay. Here is what experts said in 2016 when. Now, what would be the next word?
In this case, but
very good. But as you might have understood, same kind of similar kind of combinations. And what would be the next word then?
City in this case, but yeah, it depends upon the
exactly. Exactly. So what Google and these guys do is they take these like millions and billions of news postings, okay, or standard English text, and they train them using a window. Okay, so how do I explain this properly? Okay, let me see if there is a tool, or maybe I can draw this, not a problem. Okay, so if I were to explain that I am to the mall. Okay, so the idea is you have a limited window, and let's say this is your input, and this is the true y. Okay, y true means this is coming from the data, and the idea is you will have to teach your system to take these as inputs and output the, and same when the window changes, then the outcome is mall. Okay, now as you rightly said, it is very personal. Remember that exercise that we did on WhatsApp groups. Did anyone see those outcomes?
Yes.
So did you see that it was very personal, like for each the outcome was different?
Exactly. That means
Exactly.
the training set is different for everyone. So
yeah, training or retraining, the original training is same for everything because a Google keyboard, right? So the original time when it was trained, it was on the same data. But over the time, it can be retrained or it can be kind of reconfigured to serve you better so that it becomes slightly better in predicting what you want to say, right?
So basically neural network is going on behind.
Yeah, exactly. It might be going on a server actually. It might not even going on your phone because
Yes.
and over from there Google is regularly sending the data over there, and then again all the inference is trained and that model is updated according to your use cases. Okay.
Yes.
Okay. So this is the basic idea of text generation, but that actually raises a very good question that Was it clear? Like, did you understand what I explained?
Yeah, I understood, but the question of identifying what context to pick is one way could be that it automatically is because I give a probability of 0.9 in this case to if I am comparing in a jungle cat and a lion, then the probability of it being a biological comparison is 0.9. But if I'm sitting at home and talking to a kid, then cat and dog probability will be 0.8 or 0.9 because we're talking about domesticated animals.
Right.
So that is there depending upon the training which is there. But when the system is asked a question, because finally everything is mathematical, the context alignment is where the intelligence comes in some bit of, and that's the way at least I am thinking that.
Yeah, of course,
isn't it? So that context alignment, how does it identify that in this case I have to take biology, or in this case, or is it because of the scenario, depending upon what the combination of words basis that it can determine that this is a biological comparison, so let me take this, or depending on the combination of words which are coming in, it can decide it is a family-based discussion, and I can take a
Okay, I got it, no problem. Okay, so the answer to this question is slightly much more nuanced that I want to basically say, but it is actually much more nuanced. So the thing is, there are some really good models available in neural networks specifically. One happens to be long short-term memory. And now again, this is the problem, and this is why I don't want to go in the whole discussion immediately, because it will definitely take us in a completely different direction. But okay, just to explain you what is happening is, now all of this is maths. You are currently identifying that perfectly correct. Okay. Fundamentally, what happens is in these ones, we have created logical gates, like the CT that you are looking is a context gate. Okay. So what happens is at the end, everything is matrix multiplication. So this is multiplication. This is addition. Okay. So it is nothing. It is, and these XTs are your inputs, and ST is the hidden state from the previous one. So this is called hidden state. So the idea is, and this is context, and this is hidden state from the previous one. The idea is it is carried over cell to cell while deciding. So what happens is based on the text. Now this is where embedding idea comes first. Like without understanding embedding, it will be impossible to explain this one. But this is the basic idea that it comes from cell to cell and it is kept transferred. Now sometime it will be forgotten. So that is the forget get is important for. Sometime input will be directly merged with the context. And that will give you the better prediction, and that should count as the output. So the idea is basically it will just get into a bit more complicated math, and there are better like okay, and then we have these attention mechanisms, which are basically the same idea at the end of the day, that based on the context vector, it tries to figure out, so these are your inputs, and this is a context vector that is supplied from the another machine or another part of that same machine. And based on that, if you do the correct multiplication or addition, it tends to figure out the correct word. Okay, now the mathematics is a bit nuanced, okay, to be very honest. It is not that easy to understand, but once you get the hang of it, how things work out, you can work out the basic mathematics of like attention mechanisms and stuff. But the idea is very same at the end of the day. That at the end, these are just numerical values, and based on the context or based on the embedding, it figures out what context you might be dealing with. And by doing your numerical manipulations, it is able to get out the your outcome or whatever system you have designed. So whatever the outcome you wanted would be displayed to you. Yeah, go ahead with your question.
No. So what I was saying was, I think I got what you're saying, that this is, in the end, it is finally putting some mathematical structure around context identification. Yeah. And it will be a pretty interesting thing to learn later, might be.
Yeah, no, but that is the thing. There is a lot of, how do I say, mathematical background, especially neural networks, that you will have to first go through to reach till here.
Yeah. Okay. I'm talking about self-learning, like next area.
No, totally. You should learn transformers, and you should definitely learn attention mechanism. But yeah, try to understand without learning the neural networks, then understanding CNN, LSTM, autoencoder, then these things can come to play. Okay. So there is like a lot of background knowledge one needs to get. But at the end, if just by figure, if you're trying to understand, this is what it is fundamentally doing. It is just going to generate a context vector based on your text or embeddings, and that will be chosen by attention mechanism, that what to select, what not to select. Again, that is also comes from training data itself. And either you can use it to convert from one language to another. You might be just be using for simple text generation problems, right? And this is how the nuanced or complicated the answer becomes after a while.
All right. Okay. Thanks.
Okay. Cool. All right.
So,
Does anyone? Yeah. Please go ahead.
Regarding this one, so the context is generated on basis of the text we are entering. Like first, if I enter I, then there are several possibilities, but he will choose the most used phrase which I use generally. Like
yeah, or whatever is available on Google News or whatever the data set has been.
And if I keep adding words to my sentence, the context will keep changing and using that network you show.
True. Yes, exactly. Okay. There is I think I'm forgetting the name. If someone wants a, I think there is a Colas blog for LSTM. Okay. Wait. I found a blog reading, which I must say that was really nice actually. I'm not sure which one is this one, but so this doesn't look like it. Although this one has tried to give a visual context. Okay, so one can basically try that how does attention mechanism works and everything. There was one where it was very animated and I personally liked it. So okay, fine. If someone wants to do some bit of self-reading right now or at some point, this is where you can at least start to look at, and maybe you will get a basic idea that what might be happening. Although I'm definitely forgetting the actual blog that I was trying to show you guys. That blog is pretty good, means especially with the mechanism, the way it has been explained, it is really amazing. These things are just pictures. Over there it was highly animated, which definitely made more sense. Okay, no problem. If I find it out, I will definitely send you that blog as well. Okay. All right. Any other questions? Cool. Okay. Now the idea is, and today, because of these questions, as you might have started to realize, it becomes extremely important to understand how do you encode or how do you embed these words in form of numbers, basically. Again, why is that necessary?
Because the computer only understands numbers.
So very good. Computer only understands or wants to deal or will be dealing with numbers itself. Okay. Now the whole problem is, how do you encode any of these texts or textual material into numbers at the end of the day? That's a big question actually. So, okay, what could be the most simplest technique to convert these words to numbers?
ASCII code.
ASCII, yes, very good. ASCII could be one of them. So you can get the ASCII of, but okay, so ASCII will give you characters, right? How would you get for words all of a sudden?
As we have make that column, we have already segregated the whole paragraph into columns, and if we put 0 or 1, if that is present or not.
Yeah, very good, very good. So you can think about like kind of one-hot encoding, but what about if the word gets repeated then? How would you capture that?
You can look for probability.
But probability would have to be, means then I would have to know the, okay, probability in what sense?
Number of words which are there, let's say, and in that, what is the repetition? That is one.
But in most cases, okay, in most lines or most sentences, the words might, apart from these stop words, the words might not repeat at all. Then wouldn't all the words get the same probability? That's my concern.
Yeah, so that's one way. And second thing is, because I'm taking the cue from auto text generator, there will be sequence of words. So you look at the probability of how the sequence of word is moving. as in I am the.
No, but sequence of words again, then you are already kind of establishing that there is some mathematical relationship without converting these things to numbers already.
Okay.
Yeah, that is a problem. That's where you want to go at the end of the day. But unless you do not convert these things to numbers properly, how would you reach there?
Okay.
Okay, because again, if you provide computer like is, it will not make any sense to it. So first, the problem is what number that is gets, or it might get ignored. That's also possible. But let's say if I were not to ignore is, what number should I provide here? Number, floating point, any way you want to think. So a simple pipeline is, as you have might understood by now, is that look, first you get your text or your files, and then the first thing is cleaning test. And that is what we did in the last session, right? Now tokenization is easy. You can just use the tokenizer. You don't have to actually worry too much here. You can build vocab or vocabulary, standard vocabulary, which can be, again, there are built-in dictionaries as well. So if you find some slangs or something, spell check or something, that can be done here. The final part is the tricky part. You want to generate numbers or vectors at the end of the day, but how to do it, we have no idea right now. Okay, so that's where we want to get, or we want to understand the mechanisms, and that is a important discussion to have. Without this, nothing else will make sense here. You will not understand how to use with neural networks or how to use it with any machine learning algorithm properly. Okay, so let's start with a simple story. A boy was walking down the street with phone in his hand. Okay, just think about it. If I were to mask these two things, what would have been your guesses? Let's say I never told you this part, and I told you there are two words that will come after this. What would have been your interpretation, or what would you have mostly suggested or predicted?
In his pocket.
In his pocket and
In his bag.
In his
his
hand.
bag, in his hand, in his bag. Yeah, there are only 2, 3. If you think, even if you think there are like what 10 million words in English corpus or English vocabulary, any standard English vocabulary, there are very few possible outcomes that could ever happen if you understand what the sentence or where the sentence is going down. Does that make sense?
Yeah.
Yeah, it is not infinite probabilities or something. There are very few plausible scenarios there where if you want to do a proper English sentence generation, that is what it can possibly take. There are only like 2, 3 outcomes. That is mostly that can happen. Okay, now the biggest problem is how would you convert these things to numeric systems where it might make sense that. So the question is, what input to feed here? So for each number, let's say I provide some kind of a, so you can try to think them in terms of probability for now. Is gets 0.9, D gets 0.1, boy gets 0.7, okay, and so on. The idea is you put them in a classifier, neural network, whatever you want to do. Okay, and then the output would be, okay, so output would be a massive array of probabilities. So this is an array. So, okay, what are these? This array is what exactly? This is your y hat or y prediction. So just take a guess maybe. What should this array be?
Best fit possible.
But what exactly?
Probability.
It is probability. I already told you. It is a probability array. But probabilities of what is the class here exactly?
next set of words.
Next set of words, or maybe let's stick by one word at a time. So basically, it is almost all the plausible English vocabulary that might have to be made available. And everything. So maybe at some point you realize going gets the highest probability and rest of them gets almost zero probability. Okay, something small values. Only going gets 0.7. So your prediction after that, after 5-6 word, that is the boy going to his home or something like that. Basically going gets a very high probability. Now, how did this happen? Where did it learn to get this probability very high, or like why it is gonna predict? If let's say if I say this is a trained classifier, that you already have trained this. Someone's mic is on.
Yeah. So this
Okay.
is based on some the input training which we did.
Yes,
Depending
right.
upon.
So let's say I show it all the English literature that I have ever read, or if I convert everything to TXT and then keep passing it on, the idea is at some point it would have seen something like this. Okay, some combination of this. And over there must be some words that would have succeeded the boy or came next to the boy. And based on those trainings, now it is gonna make those predictions.
So one point, which is the input combination can or will change depending upon the actual data which I want to test, and then based on that the output combination also will change. As in, is the boy or it might not be this time is the boy. It could be just that the boy was going in the mall and something happened. So so as these combinations change, these probabilities on the left and the right must be also changing.
No, so this is not probability, this is embedding. Let me be very clear here.
Okay.
So this is the embedding, or this is some value that you have assigned to is, okay? And these probabilities are rest of the whatever the English vocabulary is. And yes, one of them should get a very good result, or few of them will get a good result. And the machine will have to apply a softmax to figure the final answer.
Yeah, so is at 0.9 is fixed for any question or any
No.
test sequence?
No, that is the problem. It can't be.
Yeah, that's what I was saying. So it will
Yeah,
change depending upon the problem.
exactly. That is the problem at the end of the day. Because otherwise I could just assign an ID number, right, to each word. Like let's say I do not, okay, so most fundamental idea would be what? To take 10 million English words. So I think there are 10 million English words, and assign individual IDs to each of them. So I create a massive ID. So someone maybe does all this hard work in life and they create a massive ID for us. Okay. And this ID gets locked for a word, any word basically. So maybe this gets locked for the. Okay, anyone can come with this simple idea that why don't, even if there are 10 million words, we have computers at our disposal. So it is not something that we can't do it. 10 million is not a big number for a computer. Makes sense. But then what I'm trying to say is ID doesn't really capture the meaning of the, does it?
No, it does not.
And same problem with any word. Like if I just were to assign unique ID to each unique word, I could put them in a dictionary or something. I could put them in a hash map or something, but it doesn't solve the overall fundamental problem that I do not mean or understand the meaning of the. Now this meaning thing is very, how do I say, useless discussion, to be very honest. It is not even clear that computers will ever understand the meaning like the way we do, but the overall idea is to jump or try to understand, kind of give a numerical representation at the end of the day to any set of words. Now, the most common or most simplest thing that people come with is bag of words. Very simple to implement. And you guys can also do this. Okay.
Just one question before going into the topic actually. So can I ask?
Yeah, please.
In our previous example, so we saw that is the boy. Okay, so there might be two different possible. Okay, so is the boy going to shop, or is the boy taking bath? Okay, so going and taking is both of these words is getting the same probability weightage. Then how our model will predict? Okay.
Again, like this is Miss, did you take like machine learning with me or not? I'm not sure 100% here. Miss, because basically I have given this answer at some point, I guess. So basically there is a random walk programmed in, okay? If you get, it is very hard to get exactly equal probabilities in your floating points, because floating points have large amount of decimal space or decimal precision. So even if there is a small change at some decimal precision, of course, one will win. But even if you can guarantee me that no, till 17 spaces, there is no difference at all. So it will just do a random walk at the end of the day.
Okay.
It will just choose something randomly. It has to. That is the internal logic that is always programmed in.
Okay, so our output should be definitely one word only at any cost.
Of course, of course.
Okay.
Like in your keyboard text, the 3 words that are shown are top 3 words based on probabilities. The middle one is the highest. On the left one is the second highest. On the right one is the third highest. It is like Olympic stand. Like they provide the gold, silver, and bronze, right? Same way you have to remember.
Okay.
Okay, those top 3 words or top 3 probabilities are shown to you.
Okay.
And over there you choose, because they understand maybe the best one might not be the best one. So, and it keeps retraining itself. So whatever you choose, that becomes the new training data. Okay, all right.
So I have a question.
Yeah.
It might be silly, but
No, go ahead.
When we train with all those things, like I was just thinking how they store all these paths. The model, how they store all those paths. Like there are millions of dimensions. I'm just thinking from a neural network that there will be thousands of like nodes and there will be combinations. How do they store those things? How the model remembers that this is the combinations? Where they store those things?
Oh, that question. Okay, got it. No, first of all, neural network doesn't do that. I hope I have made it clear at some point, or this is the discussion problem because at some point it will go in direction of neural networks very heavy. Okay, so what happens is neural networks do not store any path. Do not ever say that, otherwise it will be really wrong. Basically, then you have not understood machine learning at all. That is never ever it does that. Okay, if that is what it was gonna do, then it's not really a learning mechanism, is it? Anyone remembers what neural network exactly does?
It will find out the weightage for each and every node, and it will try to correlate the inputs.
Fine. So what really happens? I can also give the same example for any data, right? I can also say that basically, if there is some kind of set of input, then how does it remember the path of input? See, same problem, right? What you said in words, I can actually go in any other domain and I can also make the same generalization. But do you think that is what ever happens in any classic machine learning or even in neural networks?
No, it actually calculates every time.
Yes, exactly. So never ever, so never ever say that. Otherwise, it is gonna be drastically wrong. That because again, then you are just saying it is memorizing something, which is not.
No, yeah.
Okay, so fundamentally, what happens? Again, I have to bring it down to real fundamentals here. Fundamentally, what really happens? Concept is wi dot. Actually, I should just put a dot here. Wi dot xi applied with functions after functions. Maybe there are a lot of functions. Give some kind of y, right? Would you agree with me?
Yes.
Okay. So look, even if you take the text generation part, the idea is if some set of xi has been given to you, is the boy going? Okay, or forget. Okay. So now this is x, okay, a set of x. And now y is what exactly? It's an array. Of what?
It's a probability matrix of all the outcomes which can be possible.
No, not just possible, all the vocabulary basically. You have to start thinking like that now.
Okay. But all the vocabulary, is it? Oh, that's like.
Yeah, if you are training on some global data, of course, all the English words, or at least maybe 100,000 most used English words would be at least vocabulary.
Yeah, so then it is done for so many combination on the left side. We have to have those metrics on the right side. That's like.
Yeah, that is the problem, right? So let's say at some point we get going or something where it gives me 0.7 and rest every will be the minuscule by close to as zero possible. Okay, everything will be really minuscule, and there would be, as he rightly said, he might be doing different tasks, so some other tasks might also get some probability. Now, based on this is the simplest idea that I can explain you with is, based on this calculation, I can say that it looks like with this combination and whatever weights you have. So basically, neural network task is to learn the correct weights. Okay, so in this large equation, this is the unknown basically. So this is the unknown that it needs to approximate. And the idea is if it were to approximate correctly by learning throughout the vocabulary of millions or billions of documents or news articles, at some point it will start to do it correctly. Did that make sense?
Yes. So yeah, fine tuning the weight through the training.
Yeah, that is basically the essence in the neural network or any kind of almost parametric estimation. Yeah.
So one question on this only. So the way I make it domain specific, as in I am putting it in a call center for automatic question answering bot. Then the right side will basically be all the relevant matter for all the words and the relevant sequences for the domain. Like for example, obviously it will not be talking about heart surgery for telecom. So those will not be there. It will be talking about.
Okay. Let me just stop you right there. So basically what happens is, first we take a global English standard model, because again, rules of English need to be learned first, right? So let's say I take a global model, which is openly available. These models are provided by Google, Stanford University, and a lot of good universities have made these global English models available. So let's say you have set of WIs, there is a complicated architectures and everything. Okay. Yeah. So WI plus architecture and everything. Okay. So this is neural network plus weights and everything. Now what you do is you will have to retrain this one. Okay. Now in retraining, what will happen is you will give it like a call center conversation, right? And with this call center conversation, again, it will be like hi customer support. I need a help in fixing my router. Fine, this could be a valid one, right? Now, same idea. While retraining, what will happen? Now, it is already a trained model, so it is not really starting from scratch in this world. Now, first, it will get really wrong. Okay, but okay. So, what is input and what is output here? In this, consider this as a training example. So, what is input? What is output here?
Combination on what you have marked on the red pen. That combination.
Yeah. So the red one is the input for that instance, and then this one is the outcome. Then what happens next?
Then next slot becomes the input. Yeah.
And this becomes your output. If it does it correctly, of course. Same, it will keep imagine a moving window basically. And then based on this one, maybe this one becomes the output. Similarly, you can keep moving the window and your retraining will start to happen. So again, even in customer care and a lot of these things, the hope is the standard English or the English rules or English ideas will still be available. But now it just needs to start targeting more domain specific. So mostly we retrain it, because usually whatever data that your client is going to provide is just not going to be enough for the overall training. It usually requires millions of billions of documents for such amazing training and amazing predictions that we usually see on internet. You cannot solve it by 100 documents. That's not going to really work.
So we always start with that somewhere which is already preset to some extent, like global model. So that is
exactly almost it has to be done. Otherwise, your training is not going to suffice after a while.
Okay.
Again, unless you already have millions or billions of conversations in call centers, then it's fine. Then no problem. Okay. So yeah, any question? So what is bag of words? So in sklearn, it is many times referred as count vectorizer. Very simple idea. It simply says, or it simply means is, you just calculate the frequency of it. Get the idea? What did I just tell you?
Yeah, tokenize and count them.
Yeah, that's it. That's all we are saying. That in each text object, now there is a problem here, of course, but just to explain you, in each text object, now what is a text object?
Any token?
Not exactly. How did I define text object? Document could be one of the ideas. Means I told you it could be a sentence. Anytime it is a phrase or a sentence, means collection of couple of tokens can also be called text object. Sentence, paragraphs, page, whole documents, whole books and stuff can be referred as a text object. So let's say I'm doing Google News training, okay? On Google News I'm training. So what would be my text object?
News articles.
Yeah, one
Headlines.
news article. Let's say one news article. Like again, go here. If I go here and I simply say, so one news article that you choose to study or you choose to understand, like I talk about Flipkart sale, right? Flipkart news or something like that. So they will show you that, okay, great, these topics are gonna be there and stuff. So this one news article will become my text object. Okay, what just happened here? Went for the search. So let's say I choose any article, it doesn't matter. Now, this is just one text object. Okay. So let's say if you were to scrape this one out and I hope people understand the basic idea of HTML and website design, right? Otherwise, basically I can just show you what really this is.
Yeah.
Okay. At the end, everything is either these kind of containers, or at the end you will start to realize most of the text or most of the stuff that you are looking is at the end just some kind of HTML object or a CSS design that they have basically put over there. Okay. And you can go ahead and you can see that what they are doing in the backend as well, and you can see that how many Google ads are running and everything. So it's not that it's complicated, especially like because I have worked on these things a lot, and you can actually see the instances that are running. And if you just want to simply understand that, okay, at this point, what is the source? So it will completely throw out the whole source. And basically when you scrape the website, we know which headers, under which headers we have to kick, or so we know this will be the heading, content or some kind of a content will be heading. And then we start to find out the next text, okay, that what text will be we have to read or cut it out. So this is the information basically. So there is thumbnails, so we will have to ignore those. Yeah. So from here to here, let's say there are some information that will be very important for me. So till this date time, it is maybe very important, and maybe you can ignore the rest of them. So now again, you will have to go ahead and clean the data first, no doubt. But let's say you did all this. So now tell me what is the training here? Amazon Great Indian Festival and Flipkart Big Billion Days sales. Okay. So, and let's say I include the semicolon, colon as well. So what is the outcome we are looking for when I'm training, especially if I am thinking about text generation only?
Smartphones.
Very good. And if I were to go slightly ahead of my point, God. And let's say given you have removed article, body and these things, and if I go till here, okay, given that you have removed article, body and some extra things, if I reach here, then again, what is the thing I want to predict? That.
Yes.
Yeah, and same, it will keep on going. So understand how these massive trainings are happening. Okay. Now why did I tell you is now the same problem comes back. Okay, but what did you assign the initial number for them? Right. What is the initial number for them? When you started the training, you still have to provide some numbers, right? So what is the initial number to these various tokens? Like Flipkart gets what kind of number?
Check with global models.
No, there is no global model. Let's say we are starting the training. Then what does the number Flipkart gets right now?
I code.
Sorry, I did not get that. What did you just said?
What we decided on a mere parameter like SKI codes or something. Probability.
Someone else?
Some random number for every token.
No, that will just destroy the whole system immediately.
Probability we assigned.
But that's the thing. Now, how did you come to know the probability?
The count of the Flipkart in the whole text object.
Yeah, at least something you have to start numerically first, like probability, but based on what really?
Training data that we had.
Yeah, so first in text object one, let's say that article itself is my input. Now in that, let's say we had 2000 words, ignoring the numbers and special symbols, okay? 2000 legitimate English words. Now, first you need to understand in these 2000 words, there would be a lot of repetition, especially for all these stop words. Now it depends based on your problem specific topic. Do you want to continue or do you want to delete all that? Stop words, of course. But let's say we start talking about Flipkart. Okay, now I have to assign a number here. How should I do it? Or even if just by that one article, if I were to construct my X and Y's or features, then how should I do it? Anyone? So let's say Amazon is one of the keywords, Flipkart is another. So these becomes your feature, right? Sale, India. Okay. So these becomes our features basically. Okay. And on text object one means article one. Now all of this now, depending on how many unique keywords you had, let's say we had 1200 unique words. Although I think even this is a large number given the context. Okay, let's say you have 1200 unique words. So how many columns you will create? And you're not killing any of the stop words or anything. Everything remains as it is. 1200. Very good. Now tell me what numbers each column will get for row one.
How many times Amazon has occurred? How many times
Very good.
Flipkart has occurred?
So after the tokenization, you can actually count, let's say Amazon occurs 4 times and Flipkart occurs 5 times. Sale occurs 10 times because again, that's what we are talking about. India, because the names are like that, might occur 14 times, something like that. Okay. Okay. That is very good for text object 1 or article 1. What about article 2? In the same day, I read some other news. If I want to assign that, then what happens here ideally?
It might be
Frequency changes.
One sec.
Frequency changes. Right?
Not just frequency changes. It is not that simple. First, you have to understand the number of columns should change.
Yeah. Yes. Yeah.
Why?
unique words.
The unique words may be different in the second article.
Yeah, so what will happen to overall number now of the 1200 unique column that we created? What happens to that now?
Will increase.
Yes, it will increase. You will keep on adding new words here. So now just think about, there are few new words, or maybe I will just use a different color here. Let's say there is a new unique word which was not even found in the previous one. Okay, and of course a lot of stop words will be common in both of them, so you cannot say that there would be total disjoint or something, but there is some new word or there is some new article, let's say, which can considers Bangalore, and let's say in the previous one it was not covered at all. So let's say based on Bangalore news we might get 4 here, but for rest of these things what would be our score in article 0?
0.
Very good. This is called bag of words. A very most, according to me, a mind-numbing technique that I will never use, to be very honest. But in a most simplistic way, this is what bag of words is. Did you get the idea?
Yeah.
Yes.
Amrita, so if in the article 2, there are some words which are present in the article 1 also. Then also, yeah,
So,
then also we will write the frequency of that word in the article 2, in the second row.
yeah.
Okay.
A lot of stop words are gonna be common in almost all any kind of text object that you provide. And of course, a lot of words, maybe India also gets repeated in this Bangalore article. So India will also get some frequency. Let's say I was just making assumption that India is not getting any frequency. Good. So now, did you understand what is bag of words?
Yeah.
Now, BOW is not something, to be very honest, that I approve or anything. It is just there, okay? And in sklearn, there is a simple technique to activate this, which is called count vectorizer. Again, not to bother with this, to be very honest. There are far better techniques available, but this is what you should know. So this is what you can use very easily to accept or activate the bag of words technique, basically. Okay, basically it does converts a collection of text documents to a matrix of token counts. Remember this. Okay, now remember, any kind of NLP dataset after a while will become a sparse dataset itself. Now what is sparse dataset?
A matrix where a lot of zeros are there.
Yeah, basically 90% or even greater than 90% are basically zeros itself. Okay, so it's pretty easy to understand that. Okay, so basically there are certain features, and based on that, at the end, fundamentally what you will get is you will basically get a dictionary, okay, where each term will get its own feature or its value, basically. Okay, that's all basic idea here is. And I will also show you through a bit of code actually. Okay, now try to understand these two lines. So these two are two different text objects for you. So how would I generate the vector or bag of words here?
We will collect the unique words from this two line of sentence.
Yeah, very good. So first, maybe I will get their individual frequencies in their text objects. So John gets, what is the score for John in line 1?
1.
1.
Maybe I can write it out so it will be easier for everyone. So John is 1, likes is
2.
2 is
1.
TO.
1.
Watch is
1.
2.
Let's
1.
ignore the dot for now, okay?
1.
And what? 1.
Likes we already covered.
2.
Already covered, so let's not do that.
Movies also covered. 1.
Okay. Let's come to the next line. What is the score here?
1. John is 1.
1.
1.
Everything is 1.
Cool. All right. Now, if I were to just remove the duplicates and just to figure it out, this dictionary is gonna work.
Yeah.
Okay, cool. Sorry, did I do something wrong? Okay, actually there is no pointer. Sorry, it is just display thing. Sorry, my bad. Just to display, otherwise I would have to assign them in somewhere. Okay. Now, if I were to combine them to make a bigger matrix, would that be okay? Now, because in my training data, both text objects are my training data. So let's say John likes to watch movies. Mary too also, and whatever. Okay. So what score each one is getting now based on the overall training data? John, how much score we get provide for John?
2.
Likes?
3.
3.
2 is again 2. Watches 2, movies is 2, Mary is 1, double 2 is, and also is 1. Okay, whatever, this is what your value comes. Now you start to see how the construction of matrix will happen, or how the data construction will happen at the end of the day.
Yes.
Very good. Can you tell me how much would be the feature size, or how many features would be available at the end of the day?
Unique words in as combined both the sentences.
Not both. Yeah, you can say both, or you can say in the whole training corpus, all the unique words become my vectors. So let's say, how would you initialize? Let's say you initialize with a vector size of vector size of, not the value of.
10.
Number of tokens.
Number of tokens. Let's say it is 11 for now. Okay, let's just say it is 11. Again, it will change on your training example. So just be careful. Now, what will happen once I provide the information? The training data will become something like this.
Yeah.
Make sense? Or it can become even slightly bigger, or anyways like. So the idea is, or any ways you decide is totally fine. Now remember, a big document where generated vocabulary is used may result in a vector with a lot of zeros, and it is totally okay. This is how any NLP problem is. It's just not this one. It's almost all the NLP issues are like this. Sparse vector require more memory and computational resource where modeling, and this is the biggest problem I'm trying to tell you. With neural networks, especially even worse than the memory requirement in NLP is much worse than what we run into CV, computer vision problems, or normal data sets. So this is why still the large amount of companies can still work on computer vision. Much smaller amount of companies actually ever work in natural languages, because after a while you will start to realize the cost really goes up. Okay, especially because of this fundamental issue of sparse vectors, because the vector representation that you create itself is very memory inefficient. Okay, so be very careful while using any NLP technique, that it will become very memory consuming, and that will put strain on the computational power. Okay.
Yeah.
Okay. So now think about it. While the training will happen, let's say I provide text object 1 to my neural network. Okay, now just let's worry about the first part. So what would be the value that I would try to feed for text object 1? Just take random values, it really doesn't matter here. And most will be 0. You don't have to even think about, most of the numbers are gonna be, or most of the columns are gonna be 0. But what would be the overall number of nodes for the input layer? Let's say this is your input layer.
11.
Yeah, my number of tokens. Yeah.
Number of tokens, or number of unique tokens in? Number of unique tokens in training data. Okay, now Now this is where the trouble starts. Okay, let me just ask you again. So in most of the CV problems, we tend to get a structured data. And again, these neural networks and everything deals with structured data. So computer vision is very fixed, right? Let's say we are provided 28 cross 28 picture, and let's say 8 is drawn inside. And we have to classify what it is. Now, can you see the problem with NLP data?
Yeah, that metric size is very huge here.
Yeah, no. So that is the hack that we had to figure out. Okay, just think about it. Let's say if you were not doing this hack and you were doing one pass by one pass. So what would have been the first problem you would have ran into?
How many number of nodes do you need?
Yeah, how many numbers of nodes you require, because it will change sentence to sentence or text object to text object. This is the fundamental problem. So actually in interviews, even I have tried to trick a lot of people. What I do is I simply ask them that which algorithm works best with unstructured data. And some people definitely correct me, or some people definitely give their most correct answer that actually almost no algorithm can actually work truly with unstructured data. Data has to be first formatted into a structured format and then only anything works. But some people will start PC and jumping to different things. And then I already know they don't understand this. Understand this very carefully. You have to convert it to a structured format. Otherwise it just would not work. So how did you just convert it to a structured format?
Sparse matrix.
Yes. What did you do is you took all your training data, all the training data, let's say you take, and a massive column size is made, or massive amount of columns are made. And these columns are just what? Come on. Each column is?
Each word, unique word.
Unique token, unique word, right, yeah. Now this unique token, again, try to understand, the whole length comes from total training corpus. Not one by one. If you do one by one, it is not going to work. So it makes sense that maybe now try to imagine, maybe document 1 is this long. Maybe document 2 is this long. Although I'm trying to show it continuous, it will never happen like that, but just trying to do that. And this is maybe document 3, that there is some continuity from here to all the way to here. Now, do you see the problem of unstructured? Each column, or if you wanted, I can do it in a slightly better way, maybe. Maybe I should not have merged them like this. One sec. This is column 1, or this is, sorry, row 1, my bad. Then row 2 will look like how?
Anywhere it can.
Okay. And how will row 3 look like? Although again, not continuous, they could be sparse, that's the whole problem. But now you see the problem that row 1, row 2, row 3 are fairly weird if you start looking at them. And this is what NLP data brings the challenge with.
So we fill all these extra columns with zeros.
Yes, whatever is empty, that gets 0. And that will be much more 90-95% cells. Let's not say columns, let's say cells, okay? Because that is intersection of rows and columns. 95% cells, or more than 90% cells, are just going to be zeros, plain zeros. And that is why we call them sparse matrix.
So as you said, if we combine all the rows and make it into a single row, and then we just take the position and its value, neglecting
no. That's a problem. That can work in text generation problem, and that is what we do. That will not work in text classification problem. Why? Because each text object would have its unique Y. Okay, imagine one document is negative, one document is positive. You cannot really merge all the rows, all 3 rows. Otherwise, how would you? Because no one is thinking about the final Y. each column, each row has its own Y, right? So imagine a text classification problem.
Okay, yeah.
See the problem? Then how, if you combine all three, what will happen to Y then? It's again, remember, it's a supervised example. Even if text generation feels unsupervised, it is still supervised. The thing is supervision is the next word, which comes after, let's say, 4 words. Got it? So you cannot always do this. In text generation, it is possible. You can treat all of them as a single corpus. So you can merge all the Google News, and that's fine. But in text classification, especially in sentiment analysis, you will not be able to do this. Because maybe row 1 or the first document or first sentence is basically a positive sentence. Next one is a negative sentence. Another one is again a positive sentence. So you cannot really merge all these rows.
And even in text generation, I think the grouping would matter. At least that's the way I was thinking. Let's say these are movie news. So movie news grouping would be different from medical.
Yeah. It totally depends on you. Although when Google and Stanford, these guys publish, they publish a global kind of a embedding. So they do try to merge a lot of these millions and billions of data sets, news articles, and they try to just generate. Okay, the idea is not to, what these guys do is, they are not trying to show you that how will it work with movies or sports or something. It is just trying to show you how in a general English scenario, it is able to recreate the text generation point. Okay. The idea is if you show it all kinds of domain and different kind of domains, now of course it will take a lot of time to train, and which these guys have, and these guys have like clusters of supercomputers with them. The trouble is, or not the trouble, basically the idea is, if I were to give it a context, or if I were to start writing something, based on the training, it would be able to figure out what context, or not figure out means at least approximate the context, and throw out reasonably good answers at the end of the day. When these guys publish, they do not try to make it classification based or something. It is a general English based text generation. And again, these can be put on your keyboards, and based on your uses, these would keep getting more personalized.
Okay. Yeah.
Okay. Anyone else? Because I know this gets confusing for a lot of people. So I'm trying to invest as much time as possible here. Please guys, if you have any doubts, please ask me, because later things are going to get just more complex based on this. So basically now you can't feed this kind of data to any neural network or any machine learning mechanism. So what do you do is you complete the array. You ensure the dimensionality is same for all the inputs. Sorry about it is not really aligning the way I showed you. Okay. Got it? And wherever is some value, let's say there are 4 values here, 1, 3, 4, 1. Rest everything is
0.
Same, you can think here that maybe there are some values here. Maybe 2, 3, 7, 8, and again 2, and rest again, all of them are zeros. And this is the input that is fed into a neural network or whatever kind of classifier or whatever system that you are using, doesn't matter. And rest all of them are 0. Okay, so yeah, this is the idea, guys, at the end of the day.
So how this is different from bag of words?
No, this is bag of words. No, I was just completing the idea basically. That first I will take individually, but I have to complete it to a term of matrix, right? I cannot just feed like 4 for one, next 5 inputs for next one. I can't do that. So I have to feed the fixed size all the time. So means fixed number of columns.
And you have to define what is your text object. That it is a row, or is it an article, or is it
usually in training data it would be provided like that. So in most training data, either it is an article, it is a paragraph, and some kind of y is given. Now, only that will work when it is a classification task. In a text generation, there is no output actually given, but we have to understand. You have to select a window. Let's say you select a window of 5 words. Then the sixth word is the output. Okay, guys. Any problem till here? If you have, please ask me, because I know things will get confusing after a while if you do not understand this idea.
Just one question. That's right. It may be out of the topic right now. May know where exactly we are using this test generation? Is it only for chatbot?
Yeah, like chatbot is one of the ideas. Like, have you seen Google Duplex?
Yeah.
So what do you think Google Duplex is fundamentally?
That I got it actually. So from our stand of view, so how I will be using, that's what I'm thinking. So
like didn't I show you GPT that day? What you can do with GPT these days? Means that is on API license these days. Means so Microsoft Azure. So GPT-3 would be available on Azure API basically after a while. I'm not sure it has been made available, but it will be licensed. Now basically you can create a whole article based on few inputs.
Okay.
Right. You will be able to generate. So this is like 1.5 billion release, and so I think this was the illustrated one, right? GL Armor, now I remember his name. Yeah, this is pretty good actually. See, this is what I wanted to show you at that time, and this is what I was not able to find immediately. So this is the basic idea, that at different times, if you keep getting the text, and you will see that at different time, every time, now the is the input and thing is the output. Understand? This is basically, this is going word by word right now, just to show you the explanation. And this is what they are showing, that at the end of the day, it can all be put in these neural networks with attention mechanisms, and each will be given a probability that if A, the next probability of being A is 30, but being of robot is 50%. So what should I choose? 50% of course. The next answer is robot. After robot, what next? Same idea. Okay. So text generation has a lot of users, especially chatbot is one of them. So you can make intelligent chatbots which might be able to conversate based on the person's real-time answers, not just fixed answers. A lot of chatbots or a lot of chatbot companies almost build chatbots which do not, which is not very dynamic. Okay, it only gives very fixed kind of replies. But with proper text generation techniques, you will be able to come up with chatbots which will be very dynamic in nature and very real like. You will feel like, yeah, it is, you are actually talking to a human or an artificial being. Okay. And of course, have you seen these automated replies on Google and LinkedIn these days?
Yeah.
So even that is a small idea of a text generation.
Yeah. Okay.
All right. So I will give you this link. So if anyone is interested, you can definitely go in this link, and the visualizations are pretty good. It's very hard for me to draw these things. So these are really good visualizations that they have created. So maybe you can look at them and maybe you will be able to understand attention. But again, there is a lot of neural network that is first required to understand. But you will be able to understand that how these things work. Okay. Okay, guys, back to our topic. Okay, so now this is a very hand approach. Okay, of course, I will not encourage you to do things like this. Okay, so what do I do is I want to tokenize each sentence. Okay, and John likes to watch movie. Mary likes movies too. Okay, and we want to get the tokenized first. So first part is tokenization. So first it will just do the basic tokenization. Again, you don't need to use this. There are tokenizers. You can just use them. And then based on them, I want to generate a vector. So what will happen is I will run this first. Now this is a small data, so there is really no problem. So this is all the sentences that I have. Okay, so you can see that how many sentences I have? 4, right? Yeah, 4 sentences. No, 5, I guess. 1, 2, 3, 4, 5. 5. Okay. So fundamentally what I'm doing is first I'm clearing it out, converting everything to lower, And then basic idea is I want to tokenize all of them. So what do you want to do when you tokenize? Basically, you initialize everything with zeros. And whenever you find the word in the overall vocabulary, you just increase it by 1. Okay. So what is this going to achieve at the end of the day?
Frequency.
Yeah, that's it. Every time I encounter the word, that word, and if I compare it with my vocabulary, I guess you know how to use the enumerate function, right? And if you get that word, if your word is same as whatever the W is, then you just increase the back vector for that word by 1. Yeah, you were saying something. Then I just call this, or I have also showed you, you can actually do it through sklearn in a very simple way. So I call this function generate BOW, bag of words, or you can simply call count vectorizer. That will solve your problem immediately. And how does it look like? Now this is what happens. So first you get your word list, like what, now these things are always canonically means this will be alphabetically arranged. So the overall vocabulary is available to you. Can you see the total vocabulary? So now for first one, now think about, for the first one, what is the input?
Yeah, 4 ones.
This array. Now you see for all of them, can you see that the size is exactly the same? Even the length of the overall line or the sentence is definitely different in all cases. Can you see that?
Yeah.
So what did I achieve here? I achieved a structured data set from an unstructured data. Anyone has a problem? Please go ahead and ask me.
For this Joe waited for the train, there should be 5 ones in the vector. Right?
I think I have already killed these. Let me just confirm this. Sorry. You are saying Joe waited for the train. I should have 5, right? So maybe I have killed some word which I am forgetting, or there is some mistake that has happened. The train is there, waited is also there. Okay, there might be some mistake.
We don't have it.
Sorry, which one?
The.
Is there in the next one.
Yeah, the is there. There could be a mistake. No, it is there. I have, because I remember I have not killed anything. Yeah, you are right. There is some weirdness available here that is definitely not making sense. Because there should have been a
Joe is different. There is capital J and small j.
Yes, you are right. This one, yeah, that is the problem. But didn't I already do this, or did I make a mistake here? Okay, so when I call generate BOW, okay. Sorry, my mistake. Definitely, this is my mistake. So maybe just in case. Okay, just to satisfy this, I will just do it manually for now. Although I should not have. This is not the right way. Of course, you should apply this on all the cases. So basically in BOW, when I was implementing it, I should have ensured that there should be a lowercase, which I did not. And that is what caused the problem. But wait a little. So yeah, everything just needs to be in a small case, and that should be okay. Let me just see. Yay. Did it work or not? Weird. Still didn't work.
You haven't
you
haven't run the count vectorizer.
But that is in the same code now. Why should that matter here? The count vectorizer is just a parallel trick. Okay, you can achieve that through here as well. And you can see actually in count vectorizer, it is doing it correctly. Actually, that is the whole funny thing. Here you can see there are 5 ones, and that makes sense. Weird. Why am I not getting the same answer here? So I'm doing this. I'm converting W lower, and okay, I will look into it if I have made a mistake or something like that. Okay, because definitely for the first one it is causing some issues. For rest, I think it is working correctly. But then why did it cause the issue for the first one? For that D or ZO or something, it is not picking at some point. Okay, but anyways, in count vectorizer, as you can see here in this one, it is doing the trick as it is, as intended basically. So here you have the encodings, and for each one of them, you can basically calculate the number of ones or whatever the overall encoding is provided. And you can see that how many encodings or how many the values have been provided or made one. And you will see that basically what we have been successfully able to do is convert an unstructured data into a structured data set. Now this is bag of words, but again, this is a dud technique, to be very honest. I do not really like this technique actually, because again, it really conveys no meaning at the end of the day. So where is the limitation? Limitation is semantic meaning itself. There is no meaning, right?
No, individual words are judged on the frequency. So if two words are the same frequency, then they are equal.
Yeah, that's the whole problem. So that is the fundamental issue, that fundamentally a lot of words can get the same number. It doesn't make them equal, is it? They are not. And because you can see that in the very first one, because Joe waited for the train. So Joe waited for the train. Everyone gets one. That doesn't solve my problem, because again, there is no semantic meaning that has been conveyed. And again, as you can understand, most of them is going to be just a sparse vector at the end of the day. For large documents, this vector size can be huge, resulting in a lot of computation and time. So now based on relevance, we need to ignore. But again, how do you, with BOW, you cannot really get the relevance factor anyways. It's very hard. So BOW is just two basic technique just to make you understand that how you start in NLP. But of course, these days, I don't know anyone actually who uses BOW for any kind of serious work, because it is not going to solve much problems. Is that clear?
Okay, yeah.
Okay. You have any doubt, please ask me.
I'm just curious then how we can solve it actually.
Oh, that's a long story. That will take classes. That is
Yeah.
long story. That how would you actually? Still, a lot of people are arguing that what is the best way to do this, but some vector representation is definitely better than these primitive techniques. Okay, fine. Just extending on this idea, I will not take too much time in these ideas. Again, just to include, so that I don't want to do all the work by myself. So I'm just going to download Stopwords as well as Gutenberg, where we will be able to utilize some standard so that I don't have to type and write these things. Okay. Now NLTK has these bigrams, trigrams and whatnot. Okay, so what is a bigram? Or in a general idea, I want you to understand them as n-grams. So the most simplistic idea after bag of words is, rather than taking a single word, why don't you take a combination? So if n is 2, this is referred as bigrams. Okay, so I just try to understand n happens to be integer, and if n is 1, then it is a proper bag of words. What does grams mean, or what it stands for is?
Words or tokens?
One sec. Yeah, basically 2 tokens at one time. Just give me one moment. Hey, sorry guys, I had some emergency call to take immediately. Sorry. Okay, so what I was talking about was bigrams, or basically 2 tokens at a time. So can you see any advantage here?
It will reduce the dimensions.
Are you sure?
Yeah, right. Because instead of 10 words, now we are keeping only 5 words. So.
No, very bad mistake that you just made here. Okay, so you just ran into problem of permutation and you somehow think it will be lesser. Think about now. Okay, it's very easy actually. Do you see the problem? Yes or no?
Yeah. Okay.
Now do you really see it is gonna be anything less?
No.
It is not.
Yeah.
Or again, depending how, if I want to take a trigram, I will have to take 3 tokens at a time.
Yeah.
Okay, what would be the advantage? First, let's talk about the advantage. Then I'm gonna tell about disadvantages. Let's talk about advantages here.
Context becomes better.
Context becomes better. Very good. Now there is some context here. Why? Because these different words somehow can figure out some context or can give some semantic meaning. Is that clear, or anyone is in doubt over there?
I didn't get it actually.
Okay. So like if I were to write something like with India, something like that, and then I stop and I say, okay, predict the next word. Compared to just writing India and asking you to predict the next word. Can you see the idea of context, that more words in togetherness, if they are available, you will have a better prediction with you?
Yeah.
Okay, with a single word, but again, more words at a time. So someone can say, oh, why don't we take a 10 gram? Same problem. It will become really complex and the matrix will keep becoming sparser, because those 10 combinations might be so unique that they might not ever occur in any other document. So this is generally, I can teach you in like bigram and trigram. Better is I always teach people in n-gram scenarios. Means n tokens at a time, where putting n as 2 it makes them bigram, putting n is equal to 3 makes them trigrams.
So is there an optimized gram, as in, because what you
No.
said, it becomes sparse?
No, people have given up that approach.
Yeah, I think for a conversation, the less number of grams is better, but for article, the more number.
Yeah, no, people have given up on this approach. To be very honest, with attention mechanism, people have tried to figure out or make neural networks which can figure out on how many grams or tokens to focus at a time. That is what attention mechanism is all about. Basically, people have literally given up on this idea that we will ever get to decide this, because this is very dynamic if you think about it. When you talk in sentences, how do I say? So think about reading a book. Okay, reading a book where you can, it is a pitch dark. Okay, it's pitch dark, and you can read with a small torchlight. Okay, nothing else is available to you. Now that torchlight happens to be very focused, so it is like a focus light, and let's say only 1 or 2 words are visible to you. So what you can do is, and it's just so pitch dark that next words are not immediately visible and stuff. So like only 2 tokens or 2 words are visible at a time, and let's say your brain is also trying to make a prediction. So don't you think if you have more words, if the torchlight grows bigger, and if it encompasses 5 words at a time, your prediction power will on an average become better?
It will, because of the better context, but then the probability of finding it will decrease in the document.
No, not the document. Let's not do that. Let's just stick with the text generation part. I understand where you are going to go, but let's just stick with text generation. that if I were mentally trying to predict the next word every time, wouldn't it be better, just telling it as an advantage for now, wouldn't it be better if I can see more words at a time?
Yeah.
But now you also think this is very attention divided, attention mechanism. If you think, even when you read on an average, you do keep some context that, okay, I'm reading this book and book is about this. But context can keep on changing chapter by chapter, paragraph by paragraph, right?
Yeah.
So how many words to put in attention? Because someone said, I think you also asked, right? That what is the optimized number? Unfortunately, there is not, and people have given up on this approach. That let's not jump into this optimized number. We will never find it, because based on text, let's say if it is a children's book, because children's cannot hold context for long, right? Like your 5-year, 6-year kid will, like, how many words they can even hold in their memory bank immediately to read the context? Maybe 4 words, 5 words, 6 words. Now expert reader, now I can consider myself as expert reader, because let's say I've read like what 600, 700 books in lifetime already. So I can hold multiple paragraphs together in my mind if I wanted to. That how the conversation is moving in the book. Minimum 2-3 lines at any point. You can ask me at any point what happened in 3 lines before, I can tell you. So this has been given up idea, like no one is worrying about n-grams anymore, and people have decided, no, we will go with attention mechanism. We will let the neural network figure it out. Okay, we will not do it, because that seems like a waste idea. But again, because fundamental idea needs to be taught. So I hope some people can see there is some inherent advantage, but the biggest problem is, again, someone can immediately come, then how do you know the n-gram? I don't actually. I do not know the exact number of n which will be successful in all the cases, and it kind of keeps varying based on context to context, book to book, article to article. Do you get my idea?
Yeah.
Yes. Yeah.
Okay. Cool. So how would the matrix for bigram will look like? And again, you can expand this idea to trigram, 4 grams and whatnot.
You will tokenize and then combine.
No. Okay, yeah, you are right. Is the gets its own column. My dog gets another column. And so on. Get the idea?
Yeah.
Now, whenever in a text object is the going to be a very frequent one actually. Let's say we are talking about text object 1. Text object is the will get like 5. Maybe it can repeat a lot of times. My dog only maybe repeats once. And now you can see it might end up making much more number of columns than even the single one. Okay, it's a basic permutation even if you want to try. So if I wanted to try NP1, right? My bad. Because ordering matters here. So NP1. So can anyone tell me what is the answer?
N.
Perfect. So as many tokens, as many columns. Now NP2, although this is a vague, this is an approximation, this will not be correct actually. So what would be the answer here? Almost n squared. Make sense? Now again, someone will rightly point it out that, sir, you cannot have all the combinations, because in English, not all the combinations are allowed. You will be right. And this is why I said it's an approximation. You can see it increases by order of 2, which is not good. Or power of 2, not order of 2. Power of 2, which is not good by any computational standard. This is not a good idea to keep doing this and think that your computer is going to work better. So what I can very easily say that is, if you think about it, earlier if you had 92% cells which were empty, which were 0, maybe you will have 99% cells which will be 0. See the problem?
Yeah.
So even if you think that somewhere it captures good context, that's good, but then you will have even larger number of cells, not columns, sorry, my bad, which will be 0. And this problem is gonna get worse with trigram because NP3 is and this is approximately
So can we conclude, is it always better to go with the bigram instead of trigram?
Yes, it does has yeah, comparatively, yes, you're right. It has given us some success, but again, with the modern deep neural network ideas, these ideas have been blown apart long time back, like 10-12 years ago. People have rejected these ideas that let's not do manually. Okay, the best thing which happened with neural networks is feature selection became automated. I do not have to manually select the features. That is the best part. So because again, these I am starting from the very statistical and basic purview of the NLP. That's why even we are talking about this. Someone who continuously works in neural network doesn't even like to think in these terms, because this is the part that neural networks have completely taken over. Neural networks determine which inputs are important. I hope you have seen that examples like that Tensor Flow playground. Yeah. Not PPT, just remember that website where the links were made and everything.
Yes.
Tensor Flow playground. Yeah. So I showed you, some are very weak and some are very strong. So it is neural network, or you can think it as a filter. These weights are basically a filter, which only allow few to pass through. So why should I bother about if I have large amount of training data and if I have the computation, why should I bother about which feature to select? Get the idea?
Got it.
Yeah, so that part has been taken apart and no one really cares about these techniques any days. In modern days, like I'm pretty sure no one really bothers with this. So this is the overall idea, guys, and the fundamental is, and okay, so NLTK actually supports bigrams and trigram by default. You just need to provide the clean words. What it means is, okay, so you need to get your corpus, you get your stop words, you get your basic counter, which this is a Python object collection. I'm not sure how many people have studied collections. Okay, so you just do a quick lookup for common words like the and an, and that we will kill. So all the English stop words will be thrown out immediately. What we will do is we will extend the word list. Now, what is this word list? Can anyone tell me?
It's a list of tokens.
Sorry?
Is it a list of tokens from all the novels?
No, it is list of all the unique words. Or see, I have written in the comments for all 18 novels that are available in public domain book corpus. Extract all their words, but we will kill their punctuations and we will ensure that the common stop words are thrown out as well. So now we are making this massive number of columns, which basically are all the features, right?
Yeah.
Because I told you now, what is the total number of columns?
Words.
Total vocabulary of the corpus.
Yeah.
Whatever the training corpus is, total vocabulary. So unique words, and you can throw out your punctuations, and you can throw out your special symbols. You can throw out the stop words, but rest of them needs to be there. Okay. So this is a simple trick that is converting everything to a massive word list. And then what am I doing here in the next one?
Lowercase and removement.
Okay, so it is just ensuring that it will ensure that only alphanumeric words will be taken and everything else will be thrown out, and it will convert all of them to lower one. Make sense?
Yes.
Now what I will do is I will create bigrams. So NLTK provides bigrams on the clean words. Now bigram by default means 2 gram. Okay. So 2 tokens at a time, and it will try to figure it out. and it will just try to find, okay, so now because it is gonna get really massive, so I cannot do all of that. So what I will do is I will ask NLTK to generate bigrams for the word sun. Okay, that's all. And we will run this just to show you how bigrams look like. So let it run and you will see that already the output is available because of the previous run. Now see, so now can you tell me how many combinations there would be at least?
It's almost in square.
See, in 18 novels, how many combinations of sun, although I could remove numbers if I wanted to. Can you see how many combinations are available? And this is just bigram. And I'm pretty sure some time after a certain while, these things will never get repeated either. Something will be okay in one document, but it will not be available in the other one. This is just sun and all the combinations with other words and tokens which have occurred. Okay, so you cannot say I took all the mathematical combinations. No, what at least was visible in these 18 documents, we have only showed you those. So you saw like a large amount of combinations just with the word sun. Now you can understand how big the bigrams are going to become.
Just one question here, Amitan. So, okay, so this n-grams, okay, I understand that it is not going to make any sense on the text generation law, but to find out the text similarity, can we go ahead with the n-grams?
Yeah, people have tried this. People have tried text similarity. Again, with Word2Vec, actually, you do not need to do this approach. But yeah, people earlier used to try bigrams for these kind of text similarity problems. Or, also for similarity, there are better approaches anyways. But people have tried this.
What are the other approaches? Okay.
If you guys want to wait, I can actually explain you after Word2Vec. Because without Word2Vec, I cannot explain this concept. For some reason, I just can't. Okay. However hard I try, I just always end up going in that direction. Okay, so no worries, I will explain you that part. Now you can use Ltk Tokenizer. You will have to download Punkt for that. Okay, that is the tokenizer. You tokenize it and you can run n-grams. You define how many grams, n you want, and it will do that. So now I'm using a very small corpus to do this, otherwise it will not happen. So I'm basically running a trigram 3, see? So basically I'm going to extend this idea. Basically I'm going to be running a basic bigram. No, I'm running a trigram here. Okay, sorry, I think I'm writing it wrong. Sorry, that 3 was not supposed to be there. I definitely have changed the code at some point. Okay, so bigrams, or this could be extended based on n-grams. So you just in n-grams, you have to provide the sequence. And then you just have to provide how many of them you want. Okay, if you put 2, it will show you bigrams. And if you put 3, it will show you trigrams. See? And if I were not to change the name, but just to show you what will happen if I put 3. Now, of course, the number of combinations are going to be less in a limited example. Okay, so let me just revert back to 2 here. And fundamentally, this n-gram idea, okay, can be utilized in any way you decide to use it as token. So if I want to go 4 grams or 4 grams, I can do that as well. Okay.
In bigrams, you had mentioned a word like sun, but in trigrams, you are not mentioning that.
No, this n-gram doesn't require it. N-gram, okay, so that was a bigram, okay. That is NLTK bigrams where I have to mention some kind of a word or something sequence if I just wanted to generate. But if I just want to tokenize it and if I want to get all the combination in n-gram, You just need to provide the sequence, okay? Or basically that is, again, look, sequence is nothing, it's just a token at the end of the day. So I am providing words one by one using the for loop. Can you see that?
Yeah.
Okay, so look, what is sentence at the end of the day? It is set of strings, means there are two strings, okay? Now in both strings, one by one we will go. Now, first we will take this string. To Sherlock Holmes, she is always the woman. Now what I will do is I will use tokenizer. What does tokenize does? Go ahead.
It will remove the white spaces.
And
it will create a
now it will get you individual objects, right?
Yeah.
So first two will be passed into here, right? Can you see that? And even here it has been shown to you. In the sequence, first I, let's say I have seldom heard. Okay, so first that is passed here, total 12 items. So first word is, let's say I. So first the bigrams will be made of what?
I and have.
Sorry, did I just print out? Just let's run this once again. No problem.
That is the last sentence, I think. Yeah.
Yeah, no problem, no problem. Okay, so let's start with whatever it detected first. So if you use tokenize, it will not do it in a canonical order. It will find whatever is first and it will start. So it goes with to Sherlock. Now, again, as I said, it will not find all the, it is not a mathematical trick. It is not trying to do permutation combination. It will only try to find what is available in the text. So to Sherlock is available. And as you can see, 2 is not available anywhere else. So it will not come, right? Now, so it will leave that. It will go for the next token, Sherlock. For Sherlock, 2 and Sherlock has already been covered here. Again, remember, it's not a mathematical combination. It doesn't have to do Sherlock 2. It will only do what it sees over there. So with Sherlock, what is the combination it finds? Sherlock Holmes, then Holmes and C. So even if you see some repetition, that will be captured here. Understand?
Yes.
So what's the point, as in there, it is basically taking sequences of cutting the sentence into two by taking every word and taking the next word.
Yeah, that is the most simplest explanation. But the problem is, because this is a very small example, right?
Yeah.
Now the problem is, like if you were to take Gutenberg here, what we have done with bigrams, see, just with Sun, because there are 18 novels over there, okay, there would be so many combination of so many words.
So yeah, so that's what I was going to ask, that when we said 2, it did not take Sherlock Holmes with all the words. It did not say Sherlock Holmes. Sherlock.
Yeah, no. Please do not. That's what I was always trying to tell. It's not a mathematical permutation that has happened. That was just to show you the complexity of the equation, because we had to do the math, right? It will only show what the examples in all the 18 novels has happened. So in all the 18 novels that Gutenberg contains, it tried to find all the bigram settings of Sun.
Yeah, so like for example, in this case, if you see sun freighted, sun die, sun stars. Now, these combinations
have occurred in these 18 documents.
Have occurred in these 18 documents with these words either before or after sun. All right. So
yeah. Either Sun will be first or either Sun will be second. That's what's going to happen. Okay. That is what the whole idea is.
So the complexity you shown, like n square or n cube, that is the at max complexity.
At max, yeah. Means like, yeah, in computer science, like I am from computer science, right? So I will always talk in big O, right? So you understand what big O means, right?
Yes.
This is the worst case, of course. In real English, it will never reach n cube. It will be much, but it is the upper bound that I have put here. And I said, of course, it will be worst case scenarios n cube. Of course, the real world will be somewhere underneath it. Even there are 10 million words in English, it doesn't mean all the combinations are possible.
That itself puts some intelligence into that.
Yeah. Hey guys, so let's finish. Let's stop the lecture for today.